Hello everyone. Now I am going to discuss the question of the poll which I posted yesterday. Question was, all the electrons in a sample of H atoms jump from fifth orbit to first orbit either directly or indirectly by first jumping to other orbit then to first, but no line is found in Balmer series. Maximum number of different lines in emission spectrum is. Options were 6, 7, 9, 10. Around 27% said 6, 57% said 7, 10% said 9, 6% said 10. Let's see what is the correct answer. Guys, first of all, we need to understand what happens when electron jumps from higher energy orbit to lower energy orbit. We need to understand the concept of spectral lines. If we take H2 gas in a discharge tube and electric discharge is passed under low pressure, then radiations are emitted. If we analyze emitted radiations, it is found to consist of series of sharp spectral lines in ultraviolet region, visible region, infrared region. The series of lines is known as line or atomic spectrum of hydrogen. Please note each line corresponds to light of definite wavelength. The entire spectrum consists of 6 series of lines. You can see all the transitions of electrons from higher energy orbit to first orbit will give Lyman series. All the transitions from higher energy orbits to second orbit will give Balmer series. Similarly, Paschen series, Brackett series, Pond series, Humphrey series. Now in our question says, all the electrons in a sample of H atoms jump from fifth orbit to first orbit, and we need to avoid Balmer series, lines of Balmer series. If I draw energy orbits, fifth orbit, fourth orbit, then third, then second, then first. If I find total lines, maximum possible spectral lines, then the formula is very simple. If electrons jump from nth orbit to first, you can simply say NC2. That is factorial n upon factorial 2 factorial n minus 2. So that is n minus 1 by 2. So here in this case, we get 5 into 4 by 2, 10. Total spectral lines will be 10. But we need to avoid lines of Balmer series. That means there should not be any transition from 5 to 2 or 4 to 2 or 3 to 2. And since no electron has jumped from any higher orbit to second orbit, there will not be any 2 to 1 jump also. So, how many lines you need to ignore? 4 lines. Total 10 lines were there. You need to remove 4 lines. So, left lines will be 6. So, answer of our question is 6. We can draw here 5 to 4, or it can be 5 to 3, or it can be 5 to 1. Similarly, 4 to 3 or 4 to 1. Then 3 to 1. So these are the only lines that we need to count. How many are there? 1, 2, 3, 4, 5, 6. So answer of our question is 6. Hope things are clear to you. If you have any doubts, you can write in comment section and wait for the next poll. Till then, bye-bye.